Assalamualaikum warahmatullahi wabarakatuh to Doctor. Okay, today we are going to present a topic in the subject of Computer Architecture, ECC 3202, and we would like to present about processor, structure and function. So first of all, I would like to introduce ourselves. My name is Nur Izzah Hidayah binti Abdul Aziz and my matric number is 183354.
And me, my name is Nazira binti Ibrahim and my matric number is 183812.
So today we are going to present about
today in our presentation involve of a processor organization, register organization and instruction cycle.
Okay, for the processor organization, to understand the organization of processor, there are 5 requirements for processor must do, which are fetch instruction, where the instruction is read from memory. Next is interpret instruction, where the instruction is decoded to determine the required action. The third one is fetch data, where the data is read from memory. Next is a process data, where the execution of the instruction may require some arithmetic or logic operation. And the last one is write data, where the data is written into memory. So, to do all these things, the processor needs a small internal memory to store some data temporarily. Okay, next. This figure shows the connection between the CPU and system bus. So, system bus consists of control bus, address bus and data bus. So, in CPU, there are 3 components which are ALU, register and control unit. So, ALU will perform the arithmetic and logic operation, where the register is a minimal internal memory that consists of a set of storage location. And the last one is a control unit. Control unit will control the movement of data and instruction of processor and also control the operation of the ALU.
Okay, next I'm going to explain about register organization. Okay, there are 2 types of register, which are user visible register and control and status register. Okay, for the user visible register, it enables the machine or assembly language programmer to minimize main memory references, because register is another type of memory which is located in the CPU. So by having this user visible register, it will minimize the references to main memory. Next, for control and status register, it is used by control unit to control the operation of the processor. Okay, there are 4 types of user visible registers, which are general purpose register, data register, address register and condition codes register. For the general purpose register, it can be assigned to a variety of functions by the programmer. Means it can be multi-purpose. For data register, it is used only to hold data. Address register may themselves be or act as general purpose register and may be devoted to a particular addressing mode, which are segment pointers, index registers and stack pointer. So address register is not specific for address only, but themselves may be act as general purpose. Okay, lastly, for the collection codes in user visible register, it is partially visible to the user. Bits set by the processor hardware as the results of operations. For example, when an arithmetic operation is conducted, so the result may produce positive or negative, zero or overflow as the result. And these results is stored in a register or memory. And then a condition code is set. Next, for the control and status registers, there are four. There are also four, which is program counter. It contains the address of an instruction to be fetched. And then instruction register, it contains the instruction that most recently fetched. Memory address register, or known as MAR, it contains the address of a location in memory. And lastly, memory buffer register, or known as MBR, it contains a word of data to be written to memory. Next, I would like to explain about the instruction cycles. They include fetch cycle, execution, interrupt, and may included indirect as well for certain condition. Okay, so now I will explain more about fetch cycle. Okay, for fetch cycle, the instruction is read from the memory. Okay, and then PC, the program counter, contains address of the next instruction to be fetched. And then this address is moved to the MAR and placed on the address bus. Okay, the control unit requests a memory read, and the result is placed on the data bus and copied to the MBR, which is memory buffer register. And then the content is then moved to IR, instruction register. Meanwhile, the program counter is incremented by 1 for the preparation of next fetch. Once the fetch cycle is over, the fetch cycle will continue, will repeat, and once the fetch cycle is over, the control unit examines the contents of the instruction register to determine if it contains an operand specifier using indirect addressing mode. And then my partner Nazira will explain more about indirect cycle.
Okay, next I will explain about data flow in indirect cycle. So this figure shows the flowing of data in indirect cycle. So basically, indirect cycle is occur when indirect addressing is involved. From the indirect cycle, the rightmost m bits of the MBR that contains the address reference will transfer to the MAR, which is memory address register. Then the control unit will request the memory to get the desired address of the operand into the MBR through the data bus. Okay, next, lastly, for the data flow in interrupt cycle. So, this figure shows the flowing of data in interrupt cycle. Processor can resume the normal activity after the interrupt, but the current content of the PC must be saved first. Thus, the content of PC is transferred to the MBR, which is memory buffer register, to be written in memory through the data bus. Okay. Then the special memory location is loaded into the MAR, which is a memory address register, from a control unit, and then go to the memory through the address bus. So this all for the interrupt cycle.